So good afternoon. Today I'll be presenting on the use of KH-9 hexagon declassified spy satellite imagery for an archaeological remote sensing project in North Africa. We'll be looking at the feasibility of hexagon imagery to identify and record traditional water management features in Skoura Oasis, Morocco, and Karga Oasis in Egypt. This work has formed the basis of my doctoral research at Newcastle and aims to add to the picture of oasis development, use, and abandonment, and also possibly inform future sustainability efforts. The first portion of the talk will be a very basic overview of the history of the HEXAGON program. I know that if you've been reading the very excellent work of Martin Fowler, you may be familiar with this already, but I feel it's a necessary part of the story, so bear with me. The next portion will offer a brief overview of the methodology I used to georeference the hexagon imagery. And the last portion of the talk will discuss some of the results of the remote sensing. So here's a really quick overview of how the HEXAGON program came to be. And I'm sure most of you are familiar with this, but again, bear with me. Of course, we all know that satellite photography and remote sensing had its roots in aerial photography, which began in earnest with the first powered flight in the early 20th century. World War I saw the first aerial photos utilized to get a bird's eye view of the landscape and enemy assets. And this effort continued through World War II. The Cold War era ushered in the use of spaceborne imagery for monitoring, hold on one second, I have to scroll down, which is not working. There we go. Let's see. The Cold War era ushered in the use of spaceborne imagery for monitoring adversaries, and U.S. spy satellites began with the Corona program, which again, I'm sure you're all familiar with. Hexagon was the final and most successful of the Cold War programs, and its imagery was recently released for public use. So all of these Cold War era programs were highly classified, though soon after the Corona program ended, there were calls to declassify it in the 70s to prove to the public that the U.S. could monitor the Soviet Union as a part of an arms control treaty. But that was quickly squashed because some of the technology was still in use in HEXAGON program. In the 1990s, the CIA and the Center for the Study of Intelligence began promoting the potential of the imagery for environmental studies. And it really was U.S. Vice President Al Gore who pushed President Clinton to declassify the program in 1995. Within the year, scientists began utilizing Corona. As an aside, because I thought you would get a kick out of this, in 1996, I was involved with an archaeological project that employed an early use of Corona imagery in the field on Easter Island. We had the images enlarged, so you can see there, and printed onto foam board so that we could draw site boundaries exactly or directly onto the images as we conducted survey on the northeast coast of the island. The foam boards were cumbersome, especially with the persistent wind on Easter Island, but the basic methodology worked really well. This was actually my first use of remote sensing in the field. And yes, that's me with my head down in a cave entrance. So back to the timeline. Most importantly in the declassification history, the presidential executive order for declassification included a provision here to review further reconnaissance programs for future declassification. And this important provision is what made HEXAGON available easily for us. So now a little bit about the HEXAGON program. It was actually declassified in 2011, but it's only recently been available to the public in 2020. 19 out of 20 missions were successful, and the engineers who worked on the satellite lovingly called it Big Bird. And I have to believe this was partly because it was the size of a city bus and painted bright yellow. Also, Sesame Street started around the same time, so I'm pretty sure that's why they named it that lovingly. Big Bird carried 97 kilometers or 60 miles of film, and the camera parameters and other details of the inner workings were not declassified at the same time, and they still haven't been declassified. And this is probably, at the time, due to ongoing use of that technology in other programs as well. Though I've heard differing stories on that. There's one story that says There were some interpersonal conflicts between people from the CIA and another agency. And I can tell you as a former US civil servant that that is probably partly the case. That happens quite a bit. The lack of camera parameters makes accurate orthorectification difficult but not impossible. So what makes KH-9 so much better than previously released Cold War era imagery? It had the most expansive global footprint of any Cold War era program and a high temporal resolution. There were over 670,000 scenes that were captured, and this is why it took 9 years to release to the public. All of that had to be properly inventoried and prepared for public dissemination. The charge for the imagery is low. It's about 30 US dollars and about 27 euro. But if somebody's already purchased an image, that image is free for everyone else subsequently. And of course, the resolution is much better than Corona. As you can see here, the 1976 imagery rivals that of recent open source imagery from Google Earth. So this makes hexagon imagery particularly useful for both archaeological and environmental studies, especially those that want to record land change. So hexagon's a better resource also than Corona in North Africa. Though Corona's been utilized quite a bit in the Middle East for decades now, it's not been as useful in North Africa due to its lower image resolution and low temporal resolution. The difference between Corona and hexagon imagery in North Africa is really stark. So here's a 1971 Corona image showing the fortified settlement and surrounding area of El Dabadib in Karga. You can just about make out the square shadow of the enclosed fort there. And this blurb here is actually the north wall of the fort itself. But if you had no prior knowledge of the site being there, you might actually miss this. And you can see why Corona hasn't been used quite so much in North Africa. And here is the earliest Google Earth image from 2007. You can identify that there's a structure and surrounding settlement there, but not much additional data. And here is the 1984 hexagon image, and you can see the fort, its settlement area, the perimeter wall, and even the agricultural field boundaries and the smallest boundaries within those boundaries. And this is the most recent Google Earth image here. So you can see that it rivals that current imagery we're working with on Google Earth. This adds significant value to the archaeological remote sensing tool belt. Sorry. So to utilize hexagon imagery in GIS, we first needed to rectify it, of course. And this can be accomplished in various GIS softwares, but for a higher accuracy, we completed it in ERDAS Imagine, utilizing Google Earth Pro for the identification and selection of ground control points, and the shuttle radar topography mission data for the DEM. ERDAS also requires a camera model and flying height for the orthorectification. The still classified camera model was assumed to be very similar to the later large format camera system carried on board the space shuttle, because this was the next camera that was developed by the same company, Perkin-Elmer, that developed Hexagon's camera. And it turns out that assumption was correct. So ERDAS and the assumed camera parameters allowed for photogrammetric orthorectification with a minimum of hand-placed control points and low root mean square error, which should be below 3 for best accuracy. So over the past couple of years, I've processed nearly 100 hexagon scenes in Morocco, Egypt, Iraq, and Greece, all with good accuracy. Of course, expansive areas with significant topographic variation will usually have higher error, while flatter areas will have a lower error. Sorry. Oops, why is that jumping? Sorry. So we wanted to test Hexagon's feasibility for remote sensing of archaeological sites and traditional historic water management features in North African oases. This will help to elucidate the life history of the oases and allow for an assessment of the activeness of the traditional water management systems, both historically with the hexagon imagery and recently with Google Earth Pro. As I mentioned previously, we chose Skura in Morocco and Karga in Egypt. Oops, actually, I think I missed a little bit. Hold on 1 second. Yeah. So both oases have utilized underground ancient water abstraction features called Kedera in Morocco and Kanat in Egypt. Although the origins of the technology are still unclear, they probably originated in Iran during the Persian era and spread westward through North Africa through Egypt, reaching Morocco by the medieval period. Skoura is located just south of the High Atlas Mountains and east of Ouarzazate in southern Morocco. It's an active oasis that still partially relies on Kedera, along with runoff from the mountains. Its Kedera probably were constructed in the late medieval period, as several other well-studied oases in the region have similar systems of this age. Karga, located in Egypt's western desert, has Kanat that are mostly relict. Some of the earliest systems were probably constructed during the Persian era, and then they were significantly expanded during the Roman era as the deserts were transformed into expansive agricultural fields to provide sustenance for the Roman Empire. The Kedera or Kanat, which are also known by many other names across the world, are an underground drainage gallery whose horizontal channel taps into the water table and transports the water through gravity, sometimes over many kilometers, to an outlet where it then surfaces and is then transported to, through canals to irrigate cultivation and supply settlements. The drainage gallery, the outlet, and the canals together form a complete abstraction and water conveyance system. Even though the abstraction channel is underground, the footprints are highly visible on satellite imagery since a line of vertical shafts were excavated along the line of the underground channel. These created points for access and maintenance and worker light and ventilation. As you can see, the spoil rings in the shafts show up really well in satellite imagery. These hydraulic systems were crucial in the development of the oases. They abstracted water as it was available, and thus over-abstraction from the water table was avoided. However, today, they're increasingly being abandoned in favor of more unsustainable methods, such as motorized pump wells, which over-abstract and therefore waste a lot of the water. These vanishing traditional systems were the focus of the remote sensing work. So here are current Google Earth images of Skoura Oasis on the left and Karga on the right. As you can see, Skoura is a small oasis, while Karga is a very long, narrow band of active oasis with several outlying areas of historic relict oasis. Concentrations of Kedera and Kanat are shown in red here. Despite the difference in area, both oases have about 30 to 37 distinct groups of these features, with around 100 systems in each oasis. To conduct the remote sensing, we utilized imagery from the earliest HEXAGON missions in the region from the early 1970s, and from the last missions from the early to mid-1980s, and also the time series of imagery that was available on Google Earth Pro. Then we began the digitization of the features. We utilized 1 kilometer grid squares based on the military grid reference system to conduct a complete visual scan of each oasis. We digitized each line of shafts and, where visible, each outlet and canal segments. Related sites and features were also recorded. The methodology was initially tested by a 2-week undergraduate project using Google Earth Pro, and then further refined in my research where I digitized each system on both the modern and historic KH-9 images. Detailed information about each recorded feature was collected in a database for analysis and use in GIS. And so associated features, you can see here, this is just some of the digitization, the relict fields in green and reservoirs in blue, the kanats in the pink dots, and wells and such there as well. So as a quick example, here's a 2022 Google Earth image of the northern edge of Skoura, and those are the kanats digitized in yellow. They seemingly end at the edge of the current cultivation, modern cultivation. And here is the 1982 hexagon with the Kedera in red. So you can see the full lengths of the lines of shafts, and you can also see additional segments that were destroyed before sometime after 1982. The outlets are also visible, and so are the canals. Let's see. So complete Kedera systems in this area are visible thanks to HEXAGON. We couldn't see them on the more modern imagery. So the time series from the earliest hexagon imagery onward has allowed the recent history of each Ketera system to be more clearly understood. We now have an overall picture of which Ketera were constructed in or prior to 1971, and those that have been constructed since. Those systems that were seen as abandoned and relict by 1971 are assumed to be much older and can be prioritized for future investigation, including OSL dating to understand original construction dates and any dates of modification. We now know which systems have been maintained, upgraded, and revitalized. Recent revitalization, of course, indicates that the system is still active. Here you see a traditional Moroccan Ketera system with shafts, outlet, and canal that was constructed prior to 1971. In the 1982 hexagon and the 2016 Google Earth Pro image, it appears identical to its earlier 1971 form, but by September 2017, it's been upgraded with a trenched and concreted system. So we've established a baseline inventory of Ketera and Kanats for the two study areas, and now know which ones are actively producing water. It's about 7% in Skura and 1% in Karga. We now know many Ketera have been abandoned and or destroyed. The condition of the systems and their activeness can also be monitored as more modern imagery becomes available. This is information that's not always available in official government or even archaeological records. Though some of these features have been investigated in Karga, for example, this has only occurred at a couple of major archaeological sites, and many more systems were located and recorded in this project in areas that haven't been systematically investigated yet and which are not planned for any imminent investigation. This has contributed to the overall hydraulic history of Karga and may prioritize both future work and encourage resource protection. Additionally, there's a growing interest in the revitalization of these features, and in Karga, even two of the most long-abandoned systems, we're talking Roman-era systems, have recently been reactivated and are producing water and sustaining small cultivations, like the one you see here. This was done in the last 20 years. So why is the development and abandonment of traditional oases and their water management systems important? We know that water and food security is very important right now, and it's been vital to the human story throughout time. The World Resources Institute has declared North Africa as one of the most water-stressed areas in the world, and in fact, Morocco is indicated as extremely highly stressed. There have been numerous studies into the sustainability of these oases, but very few are looking at this from an archaeological perspective. Knowing the life history of the oases, including the development, maintenance, and abandonment of them, may provide insight for future sustainability efforts. And importantly, Hexagon is a vital piece of that puzzle. It allows for a snapshot in time that captures these landscapes prior to urbanization and other destruction. This insight is not available by any other means without a lot of time and resource-consuming effort on the ground, as we all know. In conclusion, traditional water management systems are also being successfully revitalized in other areas of the world, and there's a potential that a return to these systems, such as the Ketera and the Kanat, could benefit oases in North Africa. The recent revitalization of the two ancient systems in Karga proves that some of them still have viability. I'd like to end with a photo of the snow-capped Atlas Mountains from the northern edge of Skura from some of our ground truthing field work that we did in 2022. That snow and some later precipitation recharged several of the Ketera systems in Skura and provided water for the farmers there. And the two papers there are more information about our work in those areas. So thank you.